You've probably asked the question of your teacher, when are we ever going to use this? And the Pythagorean theorem can actually be the answer to a lot of those questions. It uses multiplication facts, it uses perfect squares, it uses square roots, finding an unknown variable, and it also uses right triangles. So it's a really cool theorem, and it's actually pretty straightforward to use. So I'm going to write it down here. It's a squared plus b squared is equal to c squared. And I'm going to draw out a right triangle here like this, and we know it's a right triangle because of this little square in the corner. Okay, so let's talk about this right triangle. I like to draw that square in the corner. I like to extend it over these two lines here for two reasons. One is it kind of looks like an arrow, right? And it's pointing at this line right here, and that line is called the hypotenuse. And the hypotenuse is the longest line on a right triangle. The longest side, I should say, not line. And that we call C when we're talking about the Pythagorean theorem. And that C is right there in the equation. Okay? The other two lines, we call those legs. And again, extending this square crosses the legs, so you don't get confused about which sides are the legs and which one is the hypotenuse. And on these legs, we can call these A and B. And it doesn't matter which one is A and which one is B, because A squared plus B squared is the same as B squared plus A squared. It doesn't change anything to reverse those. And that's how the equation is written out. So it doesn't matter which one of those is A or B, but the hypotenuse, it does matter. It must belong to the longest side. Okay, so now we've got everything set up and in place, and I've actually drawn this to scale. I've drawn this leg A, 1, 2, 3, is 3 units long, and leg B is 1, 2, 3, 4 units long, and then C is 5 units long. If I were to rotate this, it should line up and be 5 of those units. Okay, so knowing this information, let's go ahead and solve our first problem using Pythagorean theorem. So A, we have labeled as the length of 3, so I'm going to say 3 squared for A. Our B is 4, so 4 squared for B, and our C is 5, that's our hypotenuse, and that'll be 5 squared. So let's start to solve it. What's 3 squared? That's 9. 4 squared is 16, and 5 squared is 25. And 9 plus 16 is 25, and that equals 25. That's pretty straightforward, right? Now, if I would have got an answer like 16 equals 29, well, obviously that's not true. But what that tells us, if we get an answer like that, it tells us, oh, that's not a right triangle, which is one of the things that you are going to be doing with these. So not only does it prove you have a right triangle, it also proves if you don't have a right triangle. So let me erase that. Now, I want to do the exact same problem, but pretend like we don't know what the length of the hypotenuse is, because that's where we're going to be using these square roots. So we've got 3 squared plus 4 squared is equal to, and we're going to leave that as C squared, right? So now again, we've got 9 plus 16 is equal to C squared. 9 and 16 is 25 is equal to C squared. this is where we're going to use our square roots. Okay? The square root of c squared is just equal to c, because c squared is a perfect square, right? Just like 25 is a perfect square. But if I take the square root of the right-hand side of this equal sign, I have to take the square root of the left-hand side. And the square root of 25 is 5, because 5 times 5 is 25. Now I've got c is equal to 5, which is what we expect to get, right? So you're going to be seeing this exact problem. Is called a 3, 4, 5 triangle. You're going to be seeing that a lot. And this is also the triangle that's used by builders. Anytime you want to build something and make it square, you want this, let me circle this, you want this corner here to be a 90-degree angle. So say you're laying out a garden, maybe one day you get the opportunity to lay out a baseball diamond. If you're building a deck, pouring concrete, building a shed, a house, a building, any of those things, you're going to be using this right here. So ask around. I'd be curious to know, and leave it in the comments. Ask around if you know anybody that's actually used the Pythagorean theorem and used a 3, 4, 5 triangle. So anyway, I hope this helps you a lot. Oh, one other thing, in case you're wondering why I've got all this up here. This is Pythagoras, and 1,000 years before Pythagoras was on the planet, this clay tablet was created. It was found in Iraq. It was found in Iraq, but back then it was Babylon. So anyway, they say that this contains the Pythagorean triples, which I'll talk about in another video. But then there's been a little question about that. I don't know. I really don't know why Pythagoras is associated with the Pythagorean theorem. He was a philosopher, smart guy. But I don't know that there's any evidence that he had anything to do with the Pythagorean theorem. And there's some evidence that maybe it was around a long time before he was. So anyway, I hope that you find that interesting, and if you get any more information on that, I'd love to hear it. All right, I hope this helps. I'll see you in the next one.